All right, this video today is going to show you how to set up a data table for your enzyme lab. Now, you collected data for one of these four independent variables, and you are only going to need to write your lab about that independent variable. You do not need to do any of the other processing. So what you want to do is just pull up the class data first and make sure you go to the tab that's appropriate for the actual experiment that you completed. You're also going to need to go to the Excel that is on a computer. You can't use the online version. You can't use the one on the Chromebook. It doesn't do everything we need it to do. So you're going to need to find a laptop that actually has Excel downloaded onto it. The Dell ones in our classroom were great. And you're going to open up a blank workbook. So you're going to be working between these two files today. So first up, make sure you know which independent variable you're going to do, and let's go ahead and start building our table. I'm going to be working along with enzyme concentration. So let's start by going to cell A2. Write down whichever variable you're going to do, and don't forget units if applicable. Now notice that this heading kind of bleeds into B and C. So I want to make this a little bit wider, but I don't want to have this be super wide. So instead I'm going to choose to do wrap text. So I'm just going to click on the cell that I've written in and click wrap text, and it's going to just move it down there. I might make it a little smaller so it looks really good. Then I'm going to list the actual concentrations that we studied. Man, I'm struggling here. Okay, now so for some of you, this is going to say pH and list the pHs. It's going to have the temperatures, etc. Going across, we're going to list our trials. Now, each trial was completed by one group. So your group is just contributing one trial to this information. Now, if you look back at the data, you're going to see that there were, for enzyme concentration, 10 different trials. So instead of writing out the numbers 10 times, the trick is to just grab this little green box in the lower right-hand corner of the cell and just pull it out until you get to trial 10 and then release, and it'll all autofill for you. Now, these trials represent our dependent variable, which is rate of reaction. So we're going to write that above these cells, including the units, which of course are millimeters per second. I'm then going to highlight the 10 cells above those trials, and I'm going to click merge and center. So that rate of reaction is representative of all of these 10 trials. Now, if I look back at my class data, we had the depth and the time, which we used to calculate the rate. The enzyme concentration we've already listed, but we're going to synthesize all of this data into one table. But the only thing we're going to take is the rate of reaction. So this next portion is going to take a minute here because we just need to do some copying and pasting, going from every trial that was conducted by someone in the class and pasting it in to our synthesized data table. Okay, so we've got all of our trials. The next thing we're going to do is we're going to need to turn this into all numeric data. Remember that NR represented no reaction, meaning the filter paper never rose in the test tube. Since we're talking about rate of reaction, if it never rose, we can call that a rate of reaction of 0. So let's turn all of our NRs into zeros, indicating that there was no reaction that occurred. Next, I want this to look really good. This is going to be in my final lab report. So what I'm going to do is I'm going to highlight everything I've done so far, and I'm going to center it. To do that, I just go to the stack of pancakes, and I choose the one that has the centered pancakes. So now it's time to do some calculations. We're going to need two calculations. We're going to first need to find the mean or average, as well as the standard deviation Oh, and standard deviation is not looking good there, so I'm going to click wrap text as well. Now, the standard deviation is a measure of how close these data points are to each other. So, for example, if I look at an enzyme concentration of 20, I'm going to see some very close data points, 0.1, 0.2, 0.3. I'm going to have a small standard deviation, meaning I'm going to have a high confidence in my mean that this is a really good accurate value. Compare that to an enzyme concentration of 80 units per milliliter. These numbers are all over the board, 26.3, 4.8. I'm going to have a much larger standard deviation, meaning I have less confidence that this is like a true mean. So let's do our calculations. To find the mean, we just hit equals to show the computer we want it to do a function for us. And then we're going to start typing in the word average, and the list of functions will pop up. We're going to choose average, and then we'll select these 10 trials like so. B3 colon K3 just means from cell B3, all inclusive is what that colon means, all the way to K3. And then just hit enter, and you'll find your mean. Now, of course, the shortcut is to grab this little box then and pull it down, and you'll end up with a mean for all 5 or 4 if you're a temperature group of your variations. The standard deviation calculation is just equals STDEV. Make sure you choose just the plain standard deviation. And you're going to choose those same cells. You don't want to choose the mean. So be sure that you have the same cells selected for the standard deviation. And then you're going to pull it down. Now, a couple of things we notice. We want to have one number after the decimal point for all of our data in this lab. And these ones are all over the place. So I'm going to select these 10 cells. And then I'm going to use these increase and decrease decimal point values. And you can just kind of play around with them until you get to the right place and you have one number after the decimal. I also have all these little error messages flagged that I just want to get rid of. So I'm going to go to this little drop down bar and I'm going to say ignore all those errors. Now they disappear. Oh, I also need to center. Now, a couple notes here. If you had a value or values in your data that were outliers, that were really far away from all of the other values, you do have the option to remove outliers from your data as you process it. But if you choose to do so, make sure that you discuss what you did in your error analysis. You need to make sure that you're really clear, and you have to be on the up and up with science of how you manipulated your data. So you may decide to just take out that one piece of data. You might take out the whole trial. If, for example, you were going to take out a whole trial, you could just do a 2-finger click, which is a right click on a column, and just click delete, and that column would disappear. You would then need to, of course, adjust your numbering. So I would just pull it out from trial 6 again. Oops. But I actually don't want to do this because that data was good. So I'm just going to undo what I did as the demo there. Okay. The last thing I'm going to do is I'm going to make this look really good. This is my personal preference. I just like to have these column headings shaded. Now you are going to print this out, so you don't want to have it really dark because sometimes when you print, the contrast isn't great. So I'm just going to make it this lightest gray, and I just think that looks nice. I'm also going to highlight that and put in some borders around the cells. So I'm going to go to this little thing that looks like a window, and I'm going to click all borders so that I can really clearly see where my borders are. So now I have some process data and I'm ready to graph. So if you look at video 2, it should help you out.